Hi students, today's topic is Sandmeyer reaction and its mechanism. It is a chemical reaction that is used to synthesize aryl halides from aryl diazonium salts using copper salts as catalyst. Therefore, using this reaction, you can prepare aromatic halides like chlorobenzene or bromobenzene from respective diazonium salts. Now, coming to the catalyst part, the commonly used copper salts are copper halides like cuprous chloride CuCl and cuprous bromide CuBr. In some other cases, depending upon the product required, CuCN is also used as a catalyst. Now let us discuss more about copper halides. These copper salts are used along with suitable halogen acids. For example, if you want to prepare chlorobenzene, the catalyst used will be copper chloride, cuprous chloride. In that case, suitable halogen acid is hydrochloric acid. And if you want to prepare bromobenzene, catalyst used would be cuprous bromide along with the acid HBr. Now, you may get a doubt here, why can't we use cuprous fluoride and cuprous iodide in Sandmeyer reaction? The answer is simple. This cuprous fluoride is a highly reactive compound, so it is not possible to handle it safely during the reaction. Hence, it is avoided. And why not cuprous iodide? See here, cuprous chloride is used for chlorination reaction. Cuprous bromide is used for bromination. In that case, cuprous iodide would be used for iodination reaction. That is to obtain, see for example, iodobenzene. But here, the nucleophile iodide, it is found to be very large as well as electron rich. That's why it is a strong nucleophile. Hence, nucleophilic substitution reactions involving iodide ion can happen readily. The rate of the reaction will be high when compared to other nucleophiles. In such a case, a catalyst is not required. But when do you call a reaction as Sandmeyer reaction? Only when copper salt is used as catalyst. That's why you cannot call direct iodination as Sandmeyer reaction. So the overall equation for Sandmeyer reaction can be given like this. You have to take a simple primary amine like aniline, aromatic amine, subject it to diazotization reaction. So the reagents used are sodium nitrite in the presence of hydrochloric acid. You have to maintain a low temperature of 0 to 5 degrees centigrade as the formed diazonium salt is highly unstable at high temperature. Once the diazonium salt is formed, treat it with suitable catalyst like CuCl in the presence of mineral acid HCl. At that time, a simple substitution reaction takes place, resulting in the formation of chlorobenzene with the liberation of nitrogen gas from the diazonium salt. So this is the overall reaction. Now we will see the mechanism of Sandmeyer reaction. The first part is diazotization reaction. I have uploaded a separate video for mechanism of diazotization. If you are interested, you may watch that. Today we will concentrate on the second part or the main part of Sandmeyer reaction, that is conversion of diazonium salt to halobenzene using copper salt as the catalyst. It is an example for substitution reaction and it follows single electron transfer mechanism. Let's see how it happens. Initially we have the benzene diazonium chloride salt. Now comes the catalyst cuprous chloride, CuCl. Here oxidation state of copper is +1. I told you that this particular reaction follows single electron transfer mechanism. So let me represent a pair of electrons of copper as 2 dots. At first, copper donates 1 electron to this nitrogen. Thereby, the pi bond shifts and positive charge on nitrogen is neutralized. So what is the product here? So we have something like this with 1 odd electron donated from this copper, nitrogen's lone pair of electron, and this nitrogen also has a lone pair of electron. So this is a free radical now. Now what happens to the catalyst cuprous chloride? It has transferred one of its electrons to nitrogen. That's why it develops a positive charge like this, Cu plus. Okay. When it donates an electron, the oxidation state increases from +1 to +2. One more electron of electron pair remains with that. So the structure of copper chloride will look like this. Now positive charge from diazonium salt is gone. It is neutralized here. So the chloride ion or the anion, it tries to find another positively charged species. That is nothing but this copper chloride. Okay. So this chloride ion establishes bond with CuCl in this fashion. So this positive charge is neutralized now because of the chloride. The oxidation state remains as +2 only. And the odd electron also remains the same. Now coming back to this radical, see if this species undergoes some changes, we can get a more stable aryl free radical from it. How can we get that? It is by the loss of nitrogen gas from this radical. How does that happen? We will see. The bond between benzene ring and nitrogen undergoes homolytic fission like this. Okay. So one electron of the bond goes to ring, other electron goes to this nitrogen. And that odd electron can combine with this odd electron, forming a bond. So N triple bond N is produced. What is this? It is nothing but nitrogen gas. So nitrogen gas is released now. What do we get? A more stable aryl free radical. Why is it stable? Because this radical is resonance stabilized. Even though it is resonance stabilized, it is a highly reactive species because it is a free radical. So it has to undergo some reaction now. This odd electron attacks on the chloro group of cupric chloride. At that time, copper chlorine bond, it undergoes homolytic fission like this. So the copper chlorine bond breaks. Now you have a chloro free radical that combines with this aryl radical, producing chlorobenzene. That is our final product of Sandmeyer reaction. Now what has happened to our catalyst? Because of the homolytic fission, this copper got one electron from this bond. Thereby it gets converted into CuCl. What has happened to the oxidation state? Since it received one more electron because of homolytic fission, the oxidation state reduces from +2 to +1. Both are same. So the catalyst is regenerated or it comes out safely at the end of the reaction. So this is the whole Sandmeyer reaction wherein benzene diazonium chloride is converted into chlorobenzene with the help of catalyst cuprous chloride in the presence of hydrochloric acid. It is a radical nucleophilic substitution reaction which follows single electron transfer mechanism. If needed, you may take the screenshot of this mechanism and the introduction part. So that is about Sandmeyer reaction. Thank you so much for watching.